Homework 5, problem 5, find the magnetic field at the center of a square loop that carries around the edges of the square a current I. Just looking at this problem and looking at the symmetry of this problem, I know that my magnetic field is going to be in the z direction, and so I'm only going to bother calculating the z hat component. And just from symmetry, I'm going to start out with that statement. What we want to use to calculate this is the Biot-Savart law. The Biot-Savart law says B, the function of R, right, is mu naught I over 4 pi integral over wherever I'm integrating over dl cross script r hat over script r squared. Okay, that's the expression that I'm going to be looking at. For us, I can also tell that the z component from each one of these structures is going to be the same, and so I only really care about one edge, and so that distance is going to be a over 2, and this distance here, right, is going to be a. Okay. The L that I care about, let's go ahead and make this the x and the y direction. Okay. The dl that I care about is this little section right here. So the direction of dl is equal to the I hat, right? It's in the I hat direction. And this R, okay, if I make my origin right here for this, the R is the distance to the point of interest, so this is R, and so that's just a over 2 j hat. The R prime is the distance to the source, which is that thing right there, and so that's just going to, let's call this distance x. That's going to be x I hat. And so from this drawing, my script R is going to be, let's see, minus x I hat plus a over 2 j hat. Okay, and again, I only care about the z component, and since my dl is in the I hat direction, when I do dl cross r, I'm only going to care about the j hat part of this thing. So my b as a function of r, just using symmetry arguments, I'm going to get 4. Okay, so that's the fact that I have one from each of these 4 edges. And then mu naught I over 4 pi. I'm going to get an integral over dx. Integral dx goes from minus a over 2 to positive a over 2. And then in the exponent, I'm only going to get an a over 2. And down here, I'm going to get, so this structure here, this r hat over r squared, of course, can also be written as script r vector over script r cubed. And so script r cubed can be written as x squared plus a over 2 quantity squared to the 3 halves power. Okay. So all I have to do is evaluate that integral. I am a very lazy person, and so I will simply use Mathematica to evaluate the integral, and in the k hat direction, of course, and I can now use that. So this b of r is going to be equal to, the 4 is going to cancel there, I'm still going to have the 2 over root 2, and so this will be 2 root 2 mu I over pi a k hat. And that's it. That is the magnetic field in the center of this square loop.